Hi there. Now in this video I want to look at the property of associativity, and if we look at this definition here, that if we take a closed binary operation, let's say defined by star here, and that's defined on a set R of real numbers, then it's associative if we have A star B in brackets, then star C equals A star, and then in brackets B star C. I'll explain this in a moment through a few examples, and this is true then for all elements A, B and C of the set of real numbers. Now we should already be familiar with this when it comes to addition and multiplication. These are associative operations, as I'll demonstrate. Suppose I take 2 plus 3 and then to this I add 4. What we've got here is 2 add 3, which we know is 5. So I've got 5 add 4, and then 5 add 4 gives us 9. And if I now change this round to do 2 plus, and then we look at doing 3 plus 4 first, then what we've got is 2 plus the total of 3 and 4, which is 7, and then 2 plus 7 equals 9. So here we have an example then showing that addition is associative for real numbers. Now I could do a similar thing to show that multiplication is associative. Suppose I take the same numbers 2, 3 and 4. Then if I do say 2 times 3 first of all and then multiply it with 4, what we've got is 6 times 4, and that is equal to 24. And if I do it the other way, that is put the 2 down but multiply the 3 by the 4 first of all, then we've got 2 times 3 fours, which are 12, and 2 times 12 is 24. And so you can see that multiplication then is also associative. Now I've got a couple of examples here where you might be asked to show that something like this was associative, or this binary operation here was associative. Now I'll run through these, but you might in fact want to pause the video at any stage and just see if you can prove that they're associative. Well, with the first one, I'll take 3 elements, let's say A, B and C, and we start then with A star B and then put star C. And so by this rule here, doing the brackets first, we're going to have for A star B the result, and I'll put this in brackets, as A plus AB, and then we star this with C. And again, following on with this definition here, what we end up with is the first element, which is this one in brackets now, so that's A plus AB, and then to this we add the first element times the second element, so we've got plus what we have in brackets, which is A plus AB, and that is multiplied by the last element here, C. And so expanding the brackets gives us AC and then plus ABC. So that's our result then when we do A combined with B first of all and then combine with C. Now to check to see whether it's associative, I now need to do A star and then in brackets B star C. So what we've got here is we'll put the A down first of all, A starred with the result of B star C. So according to this rule, it's the first element plus the product of the elements. So the first element is B, so we're going to have, and I'll put this in brackets, B plus and then BC. And then using the result again, we've got the first element, which is now A, and then it's plus the first element, which is A, multiplied by the second element there, which is B plus BC. And if I expand this out, we end up with A then plus AB plus ABC. So what we've got then is that this result does not equal this result, so it's not associative. I'll just put down here that it's not associative just by putting NA. Okay, so that's that example. Just border that off. So you might want to even try this next one now that you've seen how I've set this out. Here we've got if A star B equals A plus B plus AB. Check to see whether this one is commutative. Well, let's see how you got on. Well, you might even in fact want to just fast forward at this stage because the algebra is quite lengthy. But here we've got A star B then combined with C. And according to this definition then, if we do A star B first of all, I'll put it in brackets, we get A plus B plus AB, and then this is starred with the C. And then if we follow the definition again, we've got the first element, which is this value in brackets, so that's A plus B plus AB, and then it's plus the second element, which in this case is the C, and then it's plus the product of the elements starting with the first one. So we've got A plus B plus AB, and that is all multiplied with C. So it's just a question then of expanding this bracket, seeing what we get. So for the first few terms we've got A plus B plus AB plus the C, and now expanding the bracket gives us AC plus BC plus ABC. Now all we need to check out is whether we get the same answer when we do A starred with B star C. And again, the algebra is quite lengthy, so do fast forward if you want to just speed the process up. So we've got the first element, A star, and if we do B star C, I'll put the answer in brackets, then according to this, it's the first element, which is B, plus the second element, which is C, plus the product of the two elements. That's going to be BC. And then, using the rule again, we've got the first element, which in this case is A, plus the second, which is now going to be the values that we got in the bracket, B plus C plus BC, and then it's plus the product of the two. So that would be A multiplied with all of B plus C plus BC. And again, if we tidy this up, the first few terms are going to be A plus B plus C plus BC, and expanding the bracket, we've got AB plus AC plus ABC. And what do I notice this time? I notice that both results are exactly the same, even though the terms may be in a different order down here. So what I do notice then is that this rule holds and it's associative. So we'll just put there that it's associative. So that's associativity for you, and I hope then that this video has given you some idea of how you can prove or disprove it for various binary operations.